Okay, here's the Chapter 3 review answers. So Brian's pulling a 25 kilogram box across the ground at a constant speed. Let's underline that because that's going to be helpful for us. Of 2 meters per second. What's the coefficient of friction between the box and the ground? So coefficient of friction. We know that force of friction is equal to mu, which is the coefficient of friction, right? That's what that means, times normal force, which means that in order to get mu, we just do force of friction divided by normal force. So we need to know what those two things are. If I do a quick sketch, I know that force of gravity is going to be 25 times 10, which is 250. Actually, I'm going to make this a little bit bigger because we already have the force of Brian, which is 100. Constant speed, I underline that. That means the force is balanced, which means the force of friction is also 100. And the normal force is also 250. So here we go. Technically, okay, so I know force of friction is technically negative 100. Really, this formula should be the absolute value of the force of friction is equal to mu times the absolute value of normal force, but that's fine. So I'm just going to say 100 divided by 250 is equal to mu, and that is equal to 0.4. So that's our first answer. We need that on the next slide. He's pulling the same box, but he changed his angle. Mu stays the same, and it's 0.4. And we want to know, is the box speeding up, slowing down, or remaining at a constant speed? So you might be like, how do I know that? Well, let's make a free body diagram real quick. Still force of gravity 250. And when I was doing this in class today, period 6, people are asking, is force friction still the same? It is not, because we know we should be able to tell that normal force will change. So we've got that F Brian in the y direction is equal to 43.3 newtons. What I know about this box is that it is moving along the ground. So it's moving horizontally, right? And that means there's no vertical motion, which means that the vertical forces should still balance. So this normal force is going to be equal to, this is going to be equal to 250 from force of gravity minus 43.3. And that's going to be 206.7. So now I have enough information that I can calculate normal force, or force of friction. So I'm going to say that 206.7 times 0.4, and I'm going to get that. And force of friction is equal to 82.68. All right, and I broke my own rule. Usually I do force of gravity first and then the givens. I forgot to put the 90 in here. So now I'm going to get that's force of Brian in the x direction is 90. So let me clean this up a little bit. This should be smaller than it is. Okay, so to compare, to decide whether it's speeding up, slowing down, or remaining at a constant speed, I'm going to take a look, and I'm going to say the force of friction is 82.68. The force of Brian in the other direction is 90. These are the only two forces that do work, that speed up or slow down the object, because they are parallel to the displacement. So 90 is more than 82.68. Brian is speeding it up. Friction is slowing it down. So since Brian is pulling harder in the horizontal direction than friction is, it will speed up. Basically, Brian does more work than friction does. Okay. Joe's pulling Katie at a constant speed. There's that constant speed again. We love that. Draw her force diagram or her free body diagram. Here we go. Katie, her mass right now is 50. So her force of gravity is 500. I'm going to write it in my givens. So I've got force of Joe in the x direction. Fj x is 150. Force of Joe in the y direction is 50. Which means that the normal force is 500 minus 50. So normal force equals 450. Okay, constant speed. This is wonderful. That means that the force of friction is equal to the horizontal force of Joe, which is 150. And the question asks us after this, so this is done. Sorry. The checklist I gave you guys earlier was always do force of gravity, then do the given, then do F normal and F friction. Okay, so we got it. Force of gravity, done. The givens, done and done. And then normal force, done. Force friction, done. The next one says, what's the coefficient of kinetic friction? That's mu. Mu is equal to force of friction divided by normal force. Force of friction, 150. Normal force, 450. So it's 1/3, which is 0.33. We'll round it to 2 decimal places. All right, this is the last one. It's a little bit harder than the rest. That's okay. So here we go. Starting from rest, Sandy pushes Robbie in his sled, I'm guessing, with a diagonal 260 force. It's right there. The coefficient of kinetic friction, mu, is 0.25. Okay, draw his force diagram, free body diagram. Here we go. So force of gravity, 60 times 10, Fg equals 600. Okay, great. Now I'm going to do the givens. It's 100 down, 240 to the right. So I'm going to call this force of Sandy in the y direction, and that is 100. And then force of Sandy in the x direction is 240. Okay, last I have normal force and then force of friction. Normal force has to balance out, so the vertical forces are always going to balance, because right now we're only talking about horizontal motion. So I've got 100 plus 600. Normal force is 700. And then to get force of friction, we do mu times normal force. So 0.25 times 700, that's 175. So force of friction is 175 newtons. Okay, if we take a look at this, we can tell, and of course this makes sense, we can tell that Sandy is putting more force, more horizontal force into Robbie's sled than friction is, right? So that makes sense. That means that the 240, which is greater than 175, that means that Robbie and his sled are speeding up, which makes a lot of sense because they're starting from rest. So it would be weird if they didn't speed up. So let's go to the next slide. How fast will Robbie be going after Sandy pushes him for 5 meters? So here we go. Blast from the past, E1 plus W equals E2. E1, he started from rest. E1 is 0. Work, we have the work done by, I'm going to circle this and this. The work done by friction. I'm just going to write WF plus the work done by Sandy is equal to KE2. For work done by friction, now we're going to use this 175 as a negative, multiply it by 5, which is pointing to the right, which is positive. So we've got negative 175 times 5 plus, when we go up back to Sandy, we've got 240. We're only using the 240, not the 260, because that's what's parallel. 240 times 5. That's equal to KE2. When we do the math, we get negative 875 plus 1200. That's equal to KE2, which is going to be 325. KE2 equals 325 joules. So that's how much energy Robbie has after 5 meters. Now we need to just finish up and figure out how fast. So I'm going to move my, here we go. I'm just going to get a fresh slide. And I'm going to put the kinetic energy formula, Ke equals 1/2 mv squared. So I'm going to set 325 is equal to 1/2 the mass. When we go back, mass is 60. 1/2 times 60 times v squared. 1/2 of 60 is 30. So I'll divide both sides by 30, and I get 10.83 repeating is equal to v squared. Then I just take the square root. Now I get v equals, it's like 3 point something. Let's do it. I'm going to round to 2 decimals, 3.29 meters per second. And that's it.